talk. So the second talk is going given by two researchers, Dr. Wendy Guan and Tao Hu from Harvard University. Their presentation is data review for COVID-19 modeling. So I give you a very brief biographics about Dr. Wendy Guan is the executive director for the Center for Sociographic Analysis in Harvard University. Wendy has the PhD in ecology and GIS, and then also has natural resource management. And then Dr. Tao Hu is the postdoc fellow in the center. So they're former team for today's presentation. Welcome. So Wendy, go ahead.
Hey, Dr. Shi. Tao, are you going to
yeah, could you see my screen? I'm sharing my screen.
Okay, so you're going to advance the slides for me?
Yeah.
Thank you.
Okay.
Yeah, thanks for having me in this exciting webinar. The previous talk.
Wendy, go ahead.
You may open your mic, turn on your microphone.
Oh, I'm sorry. I thought I had turned on. Let me start again.
It's good. Yeah, go ahead. Yep.
Yeah, I thought I had a conversation with Tao already. I don't know why it got shut down again. But
there's some noisy there.
That's why. Yeah. Okay. Thanks again for having me. So I will talk briefly about the background of our research at Harvard Center for Geographic Analysis. This is a teamwork in collaboration with China Data Institute and with Wuhan University, as well as the NSF IUCRC Spatial Temporal Innovation Center, collaborating with also George Mason University. So you can see a long list of participants here. So next slide, please. Our team was assembled actually before there is a pandemic. This is a project with the mission to build a cloud-based geospatial data analysis platform for gathering, managing, analyzing, visualizing, and sharing geospatial data and knowledge. So it's sponsored by the NSF Foundation and in collaboration with, as I mentioned, the previous list of organizations and also data providers and software providers as well. Next, please. So the project was to address the challenges of collaborative research. The objective is to resolve the issue of researchers having to handle licensed data, restricted or sensitive data, data with very large size, hard to handle, right? How do you effectively use this type of data? And also, when you have to assemble all the analytical tools, where some of the licenses and maintenance and operating system requirements are complex. And also when you do your analytical work, right, you can be, one researcher can be producing valuable knowledge, but then they are not easily discoverable other than through your paper published. Your analytical process may not be replicable easily, reused by anybody else. And others may not be able to expand on what you've done. So we want to address these issues, and then in order to, at the end, very rapidly build on each other's accomplishments in research, and then have a very speedy channel for publication, teaching, and decision support. Next, please. Yeah. So we are building, at the beginning, the mission was a China Data Lab. It's a platform, cloud-based, with a virtual desktop environment, but it's really more than just a desktop. It's a data library, analytical lab, a collaboration hub, and a training center. And it's not really limited to China data. The model, the China data was the original prototype, and quickly this pandemic brought us an even more urgent appropriate prototype, which is COVID-19 research. So next, please. We have an advisory committee formed by academic as well as industry experts, many of whom I think the audience are familiar with, so I'm not going to read all their names, and they are providing the strategic guidance to our project. Next, please. Our team had started building the platform, and COVID-19 happened. So we quickly switched on to this topic and using it as our prototype to prove the value of this approach. You can see from our project website, resources COVID-19 becomes a prominent page. There are daily updates on published data, and then also a shortcut to get onto the platform and to look at the results of the team had, what the team had produced. Next, please. So we're really focused on addressing these challenges and turning them into what we want to accomplish. Integrate data, standardizing its format, making it comparable, analyzable, integrated with the spatial framework, having a permanent archive, improve the efficiency of the analytical process, and all focused so far since January, focused so far on the COVID-19 case. Next, please. In particular, our contribution is to have data not only standardized in their format, unlike what you would search on the internet, you may find many, many websites, dashboards, reporting case counts, and so on. But they are in many different geographic units. So the case counts are valuable for visual inspection. When it comes to doing academic research, we want these case counts to be in the same unit as other variables, such as demographic, economic, mobility, or anything else, right? So we are not only cleaning it up and making it standard in format, but also matching it with geographic base units. Therefore, we enrich these pandemic data with other spatial variables for geographic research. And you can see that on the right, there's a whole list of data categories that we're gathering and standardizing and sharing on the platform. Next, please. This gives you a glance of how many people had already benefited from our publications of data and other materials. Researchers from over 150 countries, and then had this many, 230,000 downloads since February. Next, please. If you come to our the cloud-based platform, this is what you will see. You not only access the data, you also access a rich pool of analytical tools, but in addition to that, you also get to an archive of analytical workflows. These workflows are published work by other researchers, and we replicated their methodology and made them a click away, so that you can come in and look at how they had used the tools and the data and constructed their model and did their analysis. And then you can pick on these and start applying your own data and your own ideas, maybe changing some of the parameters, rerun it quickly, and derive your part of the research. This is a jumpstart platform. So here you can see some examples of what types of workflows we've built and what kind of application fields it's been applied to. I'm not going to read all of them, but you can see there are a variety of areas of application that we are using workflow model on. And the results had expanded our efforts tremendously. We've received additional funding from NSF on rapid response to COVID-19. Our team had published a number of papers already. Some are also preprints, but some are already out in journals. And the data sets are also, and the publications are cited in large numbers. Next. So from here, I'm going to hand it over to Dr. Tao Wu, who will introduce the actual resources our team produced. Thank you.